Now let's spend this section rebuilding entirely from scratch our DIT. The procedures involved aren't terribly complicated, just tedious, requires mapping everything out, but it should be straightforward. So let's move forward. We'll open our notes and label this section a rebuild of the directory information tree. This exercise is useful as it gives us practice with composing and decomposing the DIT. Now we've created a new reflection of the DIT that we'd like to share, a new Visio, and it is what we intend to define the new DIT as. Let's navigate to Documents. We're into LDAP, that is. And it should be the third JPEG. Let's just confirm the name. This is the file. So here's our new DIT, or what will be our new DIT. It currently reflects what you see here. Still the overlaying top-level structure of applications referencing PEM and the name service switch interface with optional references to etc password, etc group. However, notice we've included additional organizational units: protocols, group, hosts, services, and people. These are our key OUs where we'll store information. To get to the point where we can rebuild the DIT, we first need to remove what exists. So as we know, we've got engineering, sales, people, group, and a number of other OUs. So this is where we revisit the usage of LDAP delete. So tasks include 1. Purge existing DIT using LDAP delete. Now we didn't cover recursive deletions during the LDAP delete section purposely so that we could continue to populate our DIT and then eventually tear it down, which is what we're doing now. So how will this work? Well, first and foremost, we reference LDAP delete with a bind dn, which should be familiar, manager, with the base suffix represented. We may optionally turn on verbose. We should turn on simple authentication. And the new key option is recursive. Now how do we know what to delete recursively? Well, if we take a look at the existing layout, the OU layout using LDAP search, it'll tell us. Let's history grep LDAP search, and we'll pick one of the entries which focuses exclusively on organizational units. 723 will do the trick. So here are our top level OUs beneath the base OU, which is DC equals Linux CBT DC equals internal. We want to delete all of these OUs and all of their objects. Now we've spent time importing protocol services, hosts, groups, password, usernames and passwords, among other items. All of that needs to be deleted. Now, as opposed to doing it one by one, we'll do it recursively. So what we end up doing is picking a DN, or a branch of the tree, to delete wholesale. So our LDAP command will look like the following, but we'll tack on, either between single or double quotes, the full branch that is to be deleted recursively. Let's begin with, and we can reference the recent dump. We don't want to get rid of the base DN. If you do, you'll have to recreate it as the container for subsequent OUs. So let's begin with people, followed by engineering, sales, etc. And we'll leave LDAP config since this was created by SUSE Linux. It contains objects in there for subsequent SUSE Linux deployments. We want to delete recursively OU equals people. And again, our output, our LDIF output, reflects that the people OU is the first OU. So let's remove people, followed by the base suffix dn of DC equals Linux CBT DC equals internal. This will recursively delete. Now we should indicate authentication, and this will do the trick. Now when we're done, we'll confirm with LDAP search. Let's copy this command, and the -w should be contained within. We'll move it momentarily. And the single quote is actually for the OU branch to remove. So let's include W before, just to avoid any confusion. And this will prompt us for password. Now this will return to standard out all of the objects that have been deleted. And if you scroll towards the top, if you're following along, you'll see what transpired. LDAP knows that it was instructed to delete the top level OU, but first it knows it must delete sub-objects or children of the parent object since they exist. So deleting children, and one by one it enumerates the various children or sub-objects that have to be deleted before the OU may be deleted. So sub-objects must be deleted no differently than a recursive remove like rm space -rf would work within a standard shell environment on a Linux or Unix system. So now that OU is gone, and LDAP search will confirm as such. Let's scroll towards the top, and we will see that beyond or beneath the base DN no longer exists the people OU, but rather the engineering OU. Now, how does this impact existing users? If we execute getEnt, for example, password to return users with passwords, notice they're gone. These are all local users that we see here. So those users have been deleted from the organizational unit people. How about on the Red Hat box? What's its view of the DIT? Let's history grep LDAP search and find an instance which lists organizational units. We'll grep the output for unit, and none of them search or return organizational unit information, so we can pull it from this box. Let's copy and paste over to the Red Hat box, and then scroll towards the top beneath the base DN to see if replication has taken effect, and it has. Here's the base DN, and there no longer is a people OU, but there is engineering. How about executing getEnt password? Let's see what happens. Again, these are all local users, including the user we imported to the DIT. How about getEnt group? getEnt group still returns because we've yet to delete the group OU. Now how about on the Sun side? We did not update the Sun box to process POSIX groups. So let's just note update Solaris to process POSIX group object class by referencing NIS schema. OpenLDAP included with Solaris, or the one we downloaded, the open source version, includes an NIS schema, but it needs to be referenced from the slapd.conf. Otherwise, you will not see the groups in the DIT version over on the Sunbox. And we can actually confirm that by executing LDAP search. Let's history grep LDAP search. And let's find a useful instance. Any instance will work, so we'll take this one and modify it. Let's search the OU people. In this case, we're looking for group, so people won't do. And it shows the OU, but with no contained objects, because the NIS.schema isn't in play. How about a search of organizational units from the base DN to see the replication status? And notice that the people OU has been removed as well from this slave. It has the base DN but no people OU. But the group OU does not contain the list of groups that we found over on the other boxes, SUSE and Red Hat, respectively. So with that said, let's just update the schema quickly. And that's in user local, etc open LDAP. And we want to include in slapd.conf nis.schema. Beneath the schema subdirectory exists nis schema. That's what we'll be referencing. Let's modify, and we'll copy one of the items and just modify it to reference nis.schema. Then we'll history grep kill to kill the current instance of slapd. Let's psef grep slapd to ensure that it's not running, and then let's history grep slapd to find an instance where we started it, and here's one, 455. Echo the exit status, it's clean, it's up and running. Now this means eventually the group information will be replicated over to the Sunbox. Now back to the task at hand, that is purging the entire DIT, or the relevant portions, and recreating it. So LDAP delete, we've indicated OU equals people. How about the remaining OUs? Let's navigate back to our hosts, the LDAP hosts, Linux CBT SUSE 2, and take a look at the existing layout using LDAP search. So we want to remove the remaining OUs, engineering, sales, as well as hosts and services and protocols. Now, in the interest of time, we could leave the hosts, services, and protocols OUs and simply rebuild the other OUs. So let's look at the list to pare it down. Perhaps if we removed engineering, sales, and group OUs and then rebuild them. Let's update our task. So task B will be to delete the remaining OUs, or the next OU, which will be sales. And by the way, we could indicate these common names, or distinguished names that is, in a text file and have LDAP delete reference that text file. Let's create a new file here indicating each item. And if you recall from our documentation, let's take a look at the LDAP subdirectory. We should have an example of deleting. Let's grep delete, and let's cat objects to delete.ldiff, where we simply indicate the distinguished name, such as OU equals people. So let's copy it as we see it, engineering and sales. And let's consult our LDAP search dump once more to see what else is of interest. Engineering, sales, and perhaps group. We'll leave hosts, services, and protocols. Now we'll save this as OUs to delete recursively. .ldiff. Then let's reference it from the command line using our command. So that'll be get rid of this whole block here and indicate -w, f, and OUs to delete recursively .ldiff. Now since we are connected to the local system, which is not the LDAP master, we'll need to indicate the host where the LDAP master database resides, and that's Linux CBT SUSE 2. Otherwise, the LDAP delete client will attempt to make the changes locally. Let's try this from the shell on our local system where the file exists, and this will recursively delete those 3 indicated OUs. Now it doesn't find the file, and that is because we're on the remote system. So let's try it on our local system for which we don't have a window open, so we'll open a new tab. In fact, these changes can be made as a non-privileged user in the Linux world. So let's just navigate into LDAP, where we find OUs to delete, and then connect as the root DN. We're prompted for password, and there we see the entries being deleted. Let's echo the exit status, and it's fine. Now, if there was a problem deleting any of the objects, we could have re-executed in continuous mode and optionally turn on the uppercase S option to send failed entries to a separate file for later analysis. But in this case, we see that everything executed as planned because we didn't turn on the -C option and all of the OUs were processed. Well, what does that now mean? Well, if we query from the master server the LDAP DIT, let's find a recent LDAP search in our history, we should see that the DIT structure has been pared down. So now it includes the base LDAP config, hosts, services, and protocols. With respect to our graphic, we have hosts, services, and protocols, and we need to rebuild people and group OUs, which we can do in one swoop. Now, we have LDIF entries all over the place in different documents, so let's label as our next task rebuild OUs. And these will be the OUs to store our users, so people and group, users and group information. Now, as mentioned, we have information all over the place. First and foremost, we should indicate the DIT creation of the various OUs. In other words, we need to create the top level containers before we import information into them. Now, this is where the paddle scripts can help us out, because they provide the templates necessary for making this a success. So if we execute migrate base, it dumps the standard out, the standard LDIF info required to store or to contain people and group objects. If we simply copy the LDIF statements and place it into a new file that we'll create momentarily, it gives us a basis for creating or rebuilding the tree. So we have our first two entries, which are to create the two top-level containers. Once the top-level containers have been created, we can then import entries into them. Again, we return to the paddle scripts to help us out. Let's navigate to the shell. Now we know there is a script for everything, for the key tables at least. Let's execute migrate password. It expects a file, an input file, and optionally an output file. If you don't indicate an output file, it dumps the items to standard out. Now here we have a chance to turn on extended schema support using inet.org person. Maybe that's something we're interested in doing, as it provides additional attributes. In your case, consider it if you need to support additional attributes supported by inet.org person. For simplicity, we'll stick with what worked earlier. So here are all the entries. Let's send this output to users.susa2.ldif. That way we can analyze and pare it down further. Now let's nano users.susa2.ldif, looking for anything that may not be of importance, such as some of the service accounts, @ bin, so on and so forth. Perhaps we want to populate the directory only with user accounts, such as Linux CBT SUSE2 local 1, RH local 1, Linux CBT Sun 1. Those are the key items we're interested in. But of course, if you want to migrate service accounts, then by all means do so. We're going to, for the sake of simplicity, remove the service accounts that we deem unimportant. We'll just hold Control K. Now this FTP account is a generic service account which you may or may not want to keep depending on whether or not you use the FTP service, but it's generic enough that it can be used across the board. Let's keep going through this list. Control C and Nano will tell you the percentage of the document as we currently stand and the number of lines, etc. It contains 274 lines, so it's a short document. Shortly enough we will see those key users. Let's get through MySQL, news, and other service accounts, including generic nobody, NTP for network time protocol, postfix, root. Now the root account should stay, because this account can be used in the event that there's corruption with etc password. Let's keep root. It's always good to have a backup of the root user with a password that is reflected on the other systems. www.run is another service account, and here's an account with my name on it, so we'll leave that one in there. And there we see the other accounts, SUSE2 local 1, LDAP tests, and that's it. So this is workable. Let's save the changes to SUSE2, and we will incorporate these changes into our file. Now let's count the lines in users.suse2 to see if it'll fit on the screen, and it will. So we'll less users.suse2.ldiff. Here's 50% of the document, and just copy the ldiff statements right into our new text file. That covers 2 users. Let's return to the shell and get the 3rd user Linux CBT SUSE2 local 1, followed by the 4th user Linux CBT LDAP tests. So now we're building our ldiff file with the appropriate attributes that are supported by the various object classes. So now we've got the users from the SUSE2 box. If there are any important groups, we should use our appropriate tool to export those as well, migrate group. We have a groups file, so a less of groups.suse2 will reveal the groups that are defined. Again, this is a judgment call. Do you need these particular group names? We'll take any list of group names just to populate them, so for our intents and purposes, the entire groups file will suffice. Now, we can use concatenation right before we're ready to import to send the output of groups into this new file that we've yet to save. But before doing so, to be consistent, let's just get the one user from the Red Hat side that's of interest. Let's find that window, and here we are, and we'll navigate into paddle, into the migration script subdirectory, and it's actually in this flat directory. So we can then use migrate password, etc password, dump to stand it out where we're interested again in this user, LCBT RH local 1. Now by the way, we have shown you using getEnt password how to enumerate users from the various NS switch lookup sources. At this stage, since we've emptied out the OUs, on either box, if we execute getEnt password, the users returned are from the local etc password file as opposed to LDAP, because currently no users exist in LDAP. Ditto over on the SUSE side. Local users, and let's find our Sun window. This also reflects local users, and there's a Linux LCBT Sun local 1 account that we created that we'll import momentarily. So we've pasted in LCBT RH local 1. Let's get that Sun account. Let's just double check over on the Sun side whether or not we have the migration tools. We probably do not. Navigate into our home directory. And we don't. So in temp, although we have a subdirectory LDAP, those are packages for LDAP support. Let's copy to the Sunbox the migrate scripts. We can do so from the local system. We'll simply scp star over to Linux CBT sun1 into its temp subdirectory. And we'll create a subdirectory there, paddle, for organizational purposes. So beneath temp, let's make directory paddle, and then attempt to copy these items there. We can ignore the subdirectory ADS. It doesn't include anything that impacts what we're studying, so it's not a problem. And let's try to indicate the correct password here, and there the files have been copied. So now, if we navigate into paddle, we'll see the scripts. Migrate underscore password, for example, etc password, dumps to the screen on the sun side. uname-a confirms we're on a Sunbox, albeit x86. Now here's the LDIF entry for that local user on the sun side, lcbt sun local 1. We'll copy and paste the entry into our master LDIF, and now we've got additional items. So from the top, we will create people in group OUs, followed by a number of people. At this point, we can create groups for import. To create the groups, the easy way, if we want all the groups from a particular host or from all the hosts, is to concatenate the various groups files into one file, and then concatenate that one file into this file. Now, in the interest of saving time and simplicity, since this works across the board, we'll just dump the contents of the group file into this particular text file. Now, in order to do so, we should save this file. So let's save it, and this will be our create underscore DIT. So let's label this create DIT.ldif. This is the complete create file. Then we need to get this file over to the remote system, or use output redirection to export the file on the remote system to the local system. For example, on the Linux CBT SUSE1 box, our local box, if we SSH as root to Linux CBT SUSE2, it'll prompt us. But we can send a command such as cat and the full path to the groups file which exists on the remote system, which would be LDAP paddle migration tools -47, followed by groups.suse2. So it would look like the following. Let's try this out. Since it's in root's home directory, we don't need to indicate a different directory, so we could cat the full path to the groups file, groups.suse2. Now this will send the output from the remote system back to our local system, which we could then capture and concatenate to our existing create underscore dit.ldif file. Let's try this. We're prompted, and there's something off in the path, and that should be /, let's double check it, /Linux CBT. So we're in the wrong directory, or /root, that is. Let's try it again. We're missing one directory at the beginning, and then we'll authenticate, and there's the output. These are all the groups. This output can be captured and redirected into our create underscore DIT file, which is what we meant. So let's try that. We'll send the output to, and we have to do it after the quotes to indicate that it happens on our local system as opposed to the remote system. And we'll call this create DIT groups.ldif. Echo the exit status, and now let's cat the contents of create underscore DIT groups. And that looks great. Let's scroll to the top. We'll less create underscore DIT groups. Has no funny information from SSH, which now means we can concatenate. So if we cat create underscore DIT groups LDIF using double output redirection into create underscore DIT LDIF. It's important that you use double redirection, otherwise cat will clobber the target file, meaning it'll erase everything. It truncates it, then populates it, whereas double output simply appends. So this is append redirection. Create DIT LDIF, and let's close this copy and reopen it. And that's create underscore DIT LDIF. Now notice the file is much larger. Here are all the group objects. So beneath the last user, or below the last user, LCBT Sun Local 1, we've got all the groups, at least from the SUSE box. And if you want groups from the other boxes, then you have to reconcile the differences and then import them. Of course, LDAP add will complain if there is some sort of duplicate group or duplicate object. So with that said, we have at least enough information to perform one big add. So the first step of rebuilding the OUs was to create DIT file with all objects from all boxes. Next, obviously use LDAP add to recreate the DIT. And this should be straightforward, of course. So with that said, the file exists locally on our machine. Let's history grep LDAP, and if we use LDAP delete as a template, which we have in our documentation above with the host name, let's go ahead and copy this out and just change this to LDAP add. And this becomes add. Same bind dn, and we'll be using a file. We don't need the recursive option, that gets turned off, but the file now becomes create dit.ldif, and it will happen on the remote hosts, the master LDAP server. With that said, let's try it. Now, of course, we could turn on -c in the event that there is an error, and in fact, LDAP add help returns an additional option. That's the S option. Let's scroll up to find that option, which can be quite useful. -S file name will write failed entries to a file, but we don't expect any failed entries here, so we should be good to go. Let's lsltr, and there's the create dit as our import file, and let's try which LDAP add, and we must have spelled it incorrectly, and it has an extra D. Let's check our options here. We don't have a space between the simple authentication and password prompt. Now we should be able to authenticate to the DIT and run through all these items. There it is. It's run through everything. Let's echo the exit status. It's as clean as a whistle, which means if we LDAP search, let's do a history of LDAP search, and we misspelled it, so let's navigate to the master box in the interest of saving time. History grep LDAP search, and we can pick one from the list which will enumerate the objects for us. First, let's look at the organizational units. That's 723. There we see the various OUs: hosts, services, protocols, people, group. They're added last, so they're at the bottom of the list. Then let's enumerate the objects in each. For example, 677 shows us group information, and that's history item 677. There are the groups, and if we tailor this, changing group to people, again the case is insensitive, there are the people. Now our list of users totals 7, which is much more reasonable. These are actual user accounts as opposed to daemon accounts. And of course, the ultimate test, either using SSH or getInt, to enumerate the contents of local etc password and LDAP. So let's just indicate as a follow-up use LDAP search and getInt to confirm LDAP DIT entries on our local system or on the master LDAP server. GetInt password enumerates all the local users plus the LDAP users. RH local 1, Sun local 1 come from LDAP, unbeknownst of course to any local application. Let's try the same on the serve4 box, and it's in our history. We could have searched it that way, and there we see the LDAP users. GetInt group will reveal all of the groups, including the SUSE groups on the Red Hat box. And the Red Hat release file will confirm as such. And last but not least, on the Solaris side, getInt password will reveal local, for the most part, and LDAP accounts. This Dean account for my name didn't exist prior to the recent import. It now does because of the LDAP ties. The LDAP client is still properly configured. So all is well. SSH, everything else will work. We've rebuilt our DIT. It now resembles this graphic, which includes organizational units for protocols, people, group, hosts, and services. So we've rebuilt our DIT. We'll continue our studies of LDAP.